For this lesson, we're going to talk about even and odd functions. And for even and odd functions, what we want to do is be able to determine whether the function is even or odd. So the first thing I want you to recognize is that we're going to use polynomials here. And the first thing to notice about these is if you've got them in descending powers order, so you've got the largest exponent first, you can automatically look at it to see that this is the only possibility one, with this one being x to the fourth, the only possibility it could be is even, because all of the ones with the largest exponent being even behave similarly. Now, it might not be an even function, we'll talk about that more in a moment, but that's the only possibility. It can't be odd. Same thing here, because this has an odd largest degree to it, the only possibility it could be is odd, because they all behave similarly, but it's not necessarily for sure odd. We'll determine that. So this one, again, since this has an x cubed, the only possibility is it could be odd. So that's the first thing, is intuitively to understand even and odd is based on the largest degree, but that's only with polynomials. There are other functions we could talk about as well. We're going to focus on polynomials. So when you look at the algebra of this, what happens is if you're looking for an even function, when you take the function and put in the opposite of x into the function, if that y value is the same as when you just put in x, so there's a symmetry over the y-axis, then it is an even function. Similarly, if you take the function of the opposite of x, if you put opposite of x into it, so if you look at -8 compared to 8, what's going to happen is, for instance, when you compare those, that it's going to be the opposite of the y value of the function without the negative there. So we're going to do that algebraically to be able to determine it by using the algebra of putting the opposite of x into the function. So that's how you do it using algebra. Graphing-wise, there's symmetry involved. Symmetry meaning reflection over something. So the symmetry with the graph is there's a symmetry for an even function with the y-axis. And when you're looking at an odd function, there's symmetry with the origin. Now we'll talk about what that means. But let's look at these graphs. What I've done is I've listed 3 graphs. We're going to find out that this is an even function, this is an odd function, and this is neither. Even though it looks like it might be odd, it's neither. So when we look at it, looking at the graph first, what I've done is I've picked an ordered pair. Now, one ordered pair compared to another one doesn't prove anything, but it gets that idea of symmetry here. When I look at this ordered pair, which is -1, 24 on this graph, it has to be paired up with the other x value that's not negative, the positive one, has to have the same y value to be symmetric over the y-axis. Notice it's reflected right over that y-axis, and 124 is a point on that graph. That's true of any point you pick on the graph. You pick a point on the graph, and its mirror image over the y-axis is also on the graph. So just think of the y-axis as a mirror, and there's a reflection there where this repeats itself on the other side of the mirror. This is an even function. That's how you think of it graphically. Now, for an odd function, you've got to think of it in terms of the origin. Now, reflection over the origin, really what it means is, if I were to draw a straight line, a segment down from the point down to the origin, and then just continue that and give the same segment on the other side, it will connect to the other point on the graph. That's what symmetry over the origin means. It's kind of like slope. You can think about, if you want to do rise over run, if you do rise over run, you go down this much and over this much to get to the origin. If you go down that much and over the same amount, just like you do a slope, to get to its mirror image point over the origin, then it's symmetric over the origin. What it looks like with these ordered pairs, again, that doesn't prove with the ordered pairs, but notice that this -1 and this +1, their y values are opposites. So that tells you these are the same y values, whereas with an odd function, the y values are opposites if the x's are opposites. Now for this one, notice I've got an ordered pair here for -1, 4. I compare it to a +1 for an x value, and notice this -6 is neither the same as that 4, and it's not the opposite either. So it's neither odd nor even. Now that's how you tell graphically to see how it's reflected over the y-axis for even, or reflected through the origin for odd functions. This one is neither. Okay, if I were to draw this here and continue it out here, it wouldn't hit that other point on the graph. Let's do it algebraically. Now how you do that is you take the original function here, and we're going to put the opposite of x in for it. That means wherever there's an x, I'm going to put the opposite of x. So an opposite of x here squared, and then plus the 36. Now, when you do this, I'm going to separate the opposite of x into a -1 times x. And so what I'm going to do is take that exponent, and it goes on the -1, and it goes on the x. Same thing here, -1 gets the square, and then I also have an x squared plus the 36. Now, -1 to an even power becomes 1. And so it's gone. So I just get x to the 4th. Here, -1 to the 2nd power just becomes a +1. So I get -13 times 1 is -13, x squared, and then plus the 36. Notice that's the original function. So I've shown algebraically that if you put in the opposite of x into it, you get the same as the original function. Now, this one, if I do the same process, I'm going to take the function, this one's g of x, so I'm going to do g of the opposite of x, and if I put that in wherever there's an x, I get the opposite of x cubed minus 9 times the opposite of x. Now notice if I take this and I take the -1 out, -1 cubed, and then an x cubed, -9 times the opposite of x is a +9, and then -1 to the 3rd power is just -1. I get the opposite of x cubed plus 9. Notice that if I take this and I take the opposite of this, so multiply each term by -1, opposite of x cubed plus 9x, oh this is a 9x, sorry about that, so that is a 9x there, I get the opposite y value for that. So this and that are opposites, that means that this is an odd function. Now if we try the same thing here where we're going to take h of the opposite of x and see what happens with this. So if we put in the opposite of x cubed minus the opposite of x squared minus 6 times the opposite of x, so wherever there's an x, put an opposite of x. If I take this opposite of x cubed, that's a -1 cubed, x cubed, minus -1 squared, x squared, and then plus 6. -1 cubed is negative, so I get a -x cubed. Okay, that one's okay, that's the opposite there. But notice here, -1 squared is a +1. I've got this negative in front, so it's -x squared. Notice that those aren't opposites. They're close, but they're not opposites. And then plus this 6 here, 6x. Okay, so I've got every term here being opposites, but this middle term isn't. And so it's not even or odd because it's not the same and it's not the opposite. So when we're looking for even and odd to recognize it, using algebra, you find f of the opposite of x by putting it in each place there's an x, simplifying when we're working with polynomials, and see if you get the exact same rule or formula. If you do, it's even. If you do that same thing here, when you put it in and you put it in and get the opposite of it, so every term's multiplied by -1, then it's odd. And if you get neither the same or the opposite, then it's neither of those two. When you look at the graphs, you're looking for symmetry. Symmetry with the y-axis, where that point, if you pick one point, its mirror image is on the other side of the y-axis. Or if you're dealing with the origin, you take a point and you draw a line and find that same length to the other side. That's a mirror image through the origin, then it's an odd function. So that's how we determine whether something's even or odd, using both algebra and also symmetry with the graphs.